Broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, we're just waiting a little bit for people to join. You're all on mute. If you do have any questions during the talk, there's in the little chat panel on thing, you can ask any questions you might have. But just give us another couple of minutes for people to show up, and then we'll kick off. So you don't need to unmute yourself to ask any questions. Okay, just give it the 2-minute rule. Okay, well let's get started. Just to quickly introduce myself. So my name is Johnny Miller. I work at Digitalis, and I'm an engineer by background. And my colleague here, Sergio, we're going to give you an introduction to Kubernetes and also around the Rancher tool set as well. So let's crack on. So I suppose Sergio is driving the slide. So Digitalis, who are we? So Digitalis, we're a consultancy and a managed service provider, and we're a close partner with SUSE around their Rancher tools. So we've got a lot of expertise on SUSE Rancher and the whole ecosystem around that. As a company, our goal is to really make it easy for our clients to adopt cloud native technologies, but also particularly with an added feature around data in that space. So we deal with obviously with Kubernetes deployments. We also deal with like data intensive applications, streaming data, and distributed data technologies. But our goal is to facilitate that platform and deployments on any flavor of Kubernetes, any cloud or data center or hybrid. So we're able to help our customers deploy all the great modern tools we all like to use and be essentially agnostic as possible to the underlying flavor of infrastructure you land on. So AWS, Google, Azure, on-prem, we can kind of get the whole thing up and running and communicating together as well. So we specialize in obviously Kubernetes, which is why we're all here, but we also have a lot of experience with cloud providers as well. So some people don't want to go down that agnostic route, but we have a lot of experience with getting the best out of the various cloud providers there are. And as I said, data is a big kind of strength of our company. We deal with lots and lots of critical systems where the data is the kind of hard part of the problem to solve, and we look after that. We build applications, etc., to do that. And the big part of our company culture is DevOps. So we're a firm believer in automation and instrumentation and repeatability around how we work, and that's how we're a small company, but that's how a company like our size is able to actually look after quite a lot of infrastructure and projects, because we invest in automation, we invest in instrumentation, so we get the kind of insights into the systems we look after easily. So next slide, Sergio. So the two things we do, so the first part of what we offer our clients is we provide fully managed services. So that's where we'll deploy the technologies we support across any flavor of infrastructure, and we'll do that 24/7 round the clock support for our customers. And we have a raft of technologies that we've got expertise in, and all the kind of war wounds and experience around looking after them in production environments. And obviously Rancher being our kind of go-to tool for what we prefer to use, but we're also a considerable amount of expertise in Kafka, Cassandra, Postgres, as well as building and developing streaming applications as well. Next slide, Sergio. And we also offer consulting services as well, and the scope of the consulting services we can provide to our clients is pretty broad. We're able to help out with the kind of architectural designs, figuring out what's the best architecture for a use case. As I said, we also do development work. A lot with the data intensive stuff. We can help our customers come up with that kind of operational design around how these technologies have to be looked after, and obviously automation. Big part of everything we do is automation. And we can also augment. We often come into our clients and we will augment their teams with some of our experts to kind of help them adopt these kind of technologies quickly. And we can also help with documentation, training, and more so a lot of enterprise system integration. And that's where we're hooking up different parts of the stack into different sources and sinks, and curating the data and flowing that data through and moving it where it needs to be and handling it in the correct way. And we're the kind of customers we often work with are customers where the sensitivity around the data and the sensitivity around the platform and the security around that is important. So we work with banks, insurance companies, connected cars, IoT, social networks, a pretty broad set of situations. But we take security very seriously as a company because of we're often looking after people's data in there. So that's us in a nutshell. So my colleague there, Sergio, he's going to take you through now a kind of an introduction to kind of Kubernetes if you're not that familiar with it, and then build upon that and show you the kind of cool stuff you can get by using Rancher for looking after your Kubernetes stuff. So in terms of questions, if you have any questions, you can't unmute yourself. So in the little chat room in the bottom panel there, if you post any questions there while Sergio is giving his talk, and then at the end there's a questions section which we can go through and answer those questions. So please feel free to post anything in there that you might want to ask, and we'll look to answer them as quickly as we can. So brilliant. All right. Well, I'm going to go on mute and hand over to you, Sergio, and off we go.
Thank you, Johnny. Morning, everyone. So let's start from the beginning. Let's start for what's Kubernetes and why we have Kubernetes in the first place. So many of you are probably coming from virtualized world. So you're using virtual machines to orchestrate your servers. The problem with using servers as your main point is that the servers require an operating system, they require patching, they require hypervisor. Often, no matter how good your orchestration is using Ansible or Puppet or Chef, your servers are not going to be always identical. It's going to be small differences between them, just the random package that gets installed or upgraded without you wanting to. In contrast, containers are small and lightweight. They're much easier to build, and because they contain all the libraries and the binaries required to run the application, they are a lot easier to support. And that's why developers do like containers, because it just makes their work more repeatable. But containers do have some issues, and the problem with containers is that you've got to be able to deploy them properly. So you need to be able to manage the container images. You need to be able to start, redeploy, and iterate through versions. In a lot of cases, you also need to be able to scale them up and down as demand changes, so auto-scaling, and running them across multiple nodes in a cluster for resilience. This is how Kubernetes came to be, because Google had thousands of containers running on their servers, and it was really difficult for them to manage them all. So Kubernetes was their answer. Kubernetes is an open source container management and orchestration platform designed for running thousands of containers at once. It groups containers into logical applications, and then it makes the management and discovery a lot easier. Kubernetes, once it's installed, is actually a cluster, and the cluster is comprised, in this case, of 3 different roles: a control plane, a etcd, and a worker. Control plane is, as the word implies, is the one that manages the cluster itself. etcd is a key store a key store to house all the cluster information. And the worker nodes is where all the containers are actually running. When I mean all the containers, I mean the user containers, not the system containers. You can see in this diagram, that's very simplified, what the Kubernetes master is doing and what the nodes are doing. So you can see on the left, it's called the controller manager and the API server, and on the right is called the nodes running the applications, the workloads. So let's look into what it means for us. In the beginning, Kubernetes began building infrastructure in the same way as before, using large homogeneous clusters. But with the experience, they quickly realized that that wasn't scalable. Different workloads have different needs, and large clusters could not adapt fast enough. Today, companies are using multiple clusters and different Kubernetes distributions. They have multi-cloud strategies, and each cloud has their own hosted Kubernetes service. When we talk about enterprise-grade adoption, it can be difficult to handle the overhead and risk introduced by not deploying, managing, and securing all the different clusters in the right way. The reality is that there is a significant need for being able to manage all these clusters in a consistent way through a consistent interface and through similar mechanisms. This is where Kubernetes management platform like Rancher brings value. Your workloads is going to vary. Where your cluster is running is going to vary. Some clusters require different technologies like GPUs. All the different branch locations that requires certain workloads to be in there. And the whole point is it really doesn't matter for us because you can set out the most appropriate cluster for each of them. Let's have a look to how Rancher accomplished that. Kubernetes environments can grow quickly in size and numbers. For instance, something we see very often is the test environments are much larger than production environments. So you're going to support multiple test environments, multiple staging environments, multiple production environments in different locations. But SUSE Rancher is a complete solution for solving the operational challenges. It provides a common management umbrella that can be laid on top of Kubernetes ecosystem. SUSE Rancher is able to manage Kubernetes, is able to manage any CNCF Cloud Native Computing Foundation Kubernetes distributions, including the 2 provided by SUSE itself, which is the RKE, Rancher Kubernetes Engine, and R3S, which is a lightweight Kubernetes distribution built for IoT and edge computing. Very importantly, SUSE Rancher can also manage the full lifecycle of the Kubernetes environments, provided by cloud providers such as Amazon KS, Microsoft Azure AKS, and Google GKE. Whether it's in the data center, in the cloud, or in the edge, as long as you build your clusters using a certified Kubernetes distribution, SUSE Rancher can run it. On the 2 layers above the cake you see on the diagram, you can see the SUSE Rancher takes care of the centralized management of the Kubernetes ecosystem, addressing key requirements. It provides life cycle management for the clusters, enabling simplified and consistent operations, such as version management, disability and diagnostics, monitoring and alerting, and centralized audit. It also provides a consistent set of users and security policies for multiple clusters. And it provides a rich ecosystem catalog of value-added services from cloud-native landscape. Let's have a look more in depth to what it can do. So let's get a better idea how SUSE Rancher works. SUSE Rancher can be deployed on a Kubernetes cluster of your choice. It supports SUSE Rancher's own distributions, RKE and K3S, but it can also be deployed on-prem, on Google, Amazon, Azure, or any other CNCF certified Kubernetes distributions. Once those clusters are provisioned, SUSE Rancher brings capabilities that allow you to centrally manage all those clusters. In addition, SUSE Rancher is not typically deployed into a completely greenfield environment. It can leverage existing systems that you already have without locking you in to a particular technology. SUSE Rancher provides a consistent UI to provision Kubernetes across any infrastructure provider. You can use SUSE Rancher as a single point of provisioning, but you can also use your existing provisioning mechanisms. So basically, if you decide to use Terraform, you can still use it. SUSE Rancher also serves as a single point for you to modify, upgrade, and backup clusters. You can manage the complete lifecycle of your clusters in a consistent way because SUSE Rancher can abstract the differences between providers. This capability is very powerful for organizations with hybrid IT or multiple cloud provider strategy because you don't have to integrate every single provider. SUSE Rancher also has first-class support for all cloud-hosted Kubernetes environments, AWS, Azure, and Google. This allows you to apply consistent processes and consistent interfaces, even if the Kubernetes cluster has not been installed by SUSE Rancher. Finally, SUSE Rancher has a powerful web UI and an even more powerful more powerful API in the backend. So I will show you at the end in the demo that the UI is actually quite good to use, but remember that the API in the backend is actually better. So you can do more through the API than through the UI. We briefly touched before the cloud support. Let's look into it. So SUSE Rancher has full cluster lifecycle management for all three major cloud providers. The first one to introduce was Amazon EKS. That was in version 2.5, but now we are in version 2.6, and Azure and Google have also been added. This is something you will also find in SUSE Rancher. It expands the ability to manage multiple cloud environments using multiple providers from a single central point, all by the Rancher UI. There are now more configuration options available, whether the cluster is being created from scratch or is an existing cluster you are importing. The existing hosted clusters with these cloud providers are treated as first-class citizens, regardless if they are deployed by some other mechanism. The full lifecycle management capabilities are performed in the same way, and users can leverage the same CNF tooling for all of them. Because it gives you a way to normalize your tooling to the CNCF functions without having to go deep and learn each cloud provider's proprietary built-in and locked-in solutions. Instead, there is a common baseline of configuration for Kubernetes that's portable across all providers. This is especially important for you as you must maintain containerized workloads on premises and in the cloud, and even more if you are working with different cloud providers in your infrastructure. Something I personally like very much about SUSE Rancher is the security focus. We see organizations migrating and deploying more critical applications on containers and clusters in production environments. SUSE Rancher provides an authentication for all clusters it manages. It uses authentication proxy that integrates with enterprises' main authentication providers like Active Directory, Okta, Google. You most likely don't want to manage different authentication systems for on-premises or on cloud clusters. SUSE Rancher reduces this complexity by integrating all the clusters with a single authentication provider of your choice. In addition, SUSE Rancher provides RBAC model to role-based access to all the users and groups at every level within the architecture. What users and groups can do at the Rancher level with central management tasks, what they can do in each individual downstream cluster that has been provisioned, and what they can do within the namespaces of a specific user. SUSE Rancher also makes it very easy to manage multiple multi-tenant clusters using constructs such as projects and namespaces. A very important capability in SUSE Rancher is the central management and security and network policies. Managing these policies is not feasible in large settings. ITOps applies to policies to SUSE Rancher. The SUSE Rancher applies these policies to cluster level, and doing a continuous fashion, there is some configuration mismatch. SUSE Rancher automatically repairs the situation. SUSE Rancher has different features for hardening the clusters. It can use cluster templates to standardize the configurations. We'll see that in a minute on the demo. It can use CAIN's benchmarks, for instance, to ensure the best practices for the Linux and Kubernetes are being applied. Talking a bit more about security, all the SUSE Rancher is part of the CVA scanning. So all SUSE Rancher images are being deployed through an internal CVA scanning process to ensure they are up to date and patched. In addition, taking advantage of SUSE Rancher, SUSE and Rancher, it's all been built lately on using the hardened company-based operating system that is SUSE, using the SUSE Linux enterprise-based container image. So those images are hardened and much better than anything you can probably find on the open market. Now, in terms of the workload, just for people that don't know what workload is, and workload when talking about Kubernetes refers to basically your application, your package application. That is the deployment with the containers and everything that is surrounding it. SUSE Rancher also provides value to your DevOps team. It provides you with a powerful UI for your workload management in a self-service to give you an alternative to managing Kubernetes with YAML files. Users can manage the lifecycle of the Kubernetes workloads in any cluster resourced by the browser. This helps with adoption of Kubernetes, but also provides the users with a better way of troubleshooting and monitoring capabilities. SUSE Rancher also provides an integrated catalog of Helm charts for you to deploy and manage. Different permissions can be granted to different teams to control who can deploy which Helm charts and who can use the catalogs. Again, for the people that don't know that much about Kubernetes, Helm charts are just package manager for workloads. SUSE Rancher also provides you with a self-service turnkey configuration and additional add-on services like log shipping, monitoring, storage, and additional tools for GitOps approach for deploying resources. We'll try to see all this free in the demo a bit later on as well. This is some of the technologies that SUSE Rancher is using. SUSE is they are very pragmatic about what the organizations use, and the SUSE Rancher is not restricted to any specific operating system, infrastructure provider, or even tool sets. It allows organizations to use anything. It's designed to manage mixed environments with open and proprietary technologies. This open and flexible approach lets you choose what's best for you. Now, after this intro, let's look into SUSE Rancher as a whole and what it cannot do. From a topology point of view, we have the Rancher management instance. The authentication proxy can be used to leverage third-party authentication sources, GitHub, Active Directory, SAML, Google, many others. The Rancher API at the core, it coordinates how to manage the requests made from Rancher. The bridge between Rancher and the downstream clusters is made through the pairing of agents and controllers. In the downstream, in the downstream, you see the agent cluster. It's basically a pod which initiates a WebSocket connection back to Rancher. There are two types of agents. The one where we're just talking about connects to the API of the specific Kubernetes cluster. But we also have a node agent which interacts with nodes in that cluster. It's a facilitator at the cluster level operations like upgrading the cluster versions, restoring etcd snapshots, and so on. It's also fallback in case the Rancher goes down. Notice that the users can connect directly to Rancher or to downstream clusters. At the configuration time, you can make this available by setting up an authorized cluster endpoint in the downstream cluster. If Rancher goes down for any reason, you don't want to lose access to your downstream clusters. The workloads will continue to run anyway because you have set these clusters in a way they are highly available. But this access requires that you can still manage if the Rancher is not available. Rancher itself is a containerized application. It's packaged as Helm chart, and once installed, it inherits all the high availability capabilities that any other Kubernetes cluster application will do. It can be installed on a cluster of any certified Kubernetes distribution. By far the most popular is RKE, but it can be anywhere. You just need 3 nodes RKE cluster for redundancy. It automatically installs Nginx ingress controller, which runs on the host network namespaces. It also exposes ports 80 and 443. And often you want to use a load balancer to connect to your Rancher. So you just need to configure the Rancher URL on the load balancer using either layer 4 or layer 7 routing. Topology is really simple. So you have Kubernetes cluster and you install Rancher on it. That's it. Keep in mind that the Rancher will not coexist with your workloads in the same cluster. The cluster will be exclusively for Rancher itself. Rancher manages the downstream clusters where typically there are several of them that run specific workloads that you have. So just to clarify that, the Rancher itself will run on its own cluster. There is no good practice for you to deploy anything else on those clusters. Those should be only for Rancher itself. Right, as mentioned before, there are different workload requirements. This is why Rancher and the SUSE team have different Kubernetes flavors tailored to the users. The first distribution was called RKE, which is the Rancher Kubernetes engine, which is aimed at data center deployments on premises or cloud. The installation is simple and fast. You can run on multiple types of platforms, It could be VMware clusters, it could be Metal servers, virtual machine instances. It supports x86 and AMD64. Sorry, ARM64, not AMD. And also Windows 20 SUSE systems. The second Kubernetes distribution is called K3S. It's a lightweight distribution and is aimed at the edge use cases. It's designed for production environments in unattended, resource-constrained locations. In addition to being lightweight, it reduces the steps needed to install, run, or update. RKE is fully certified by CNCF. It tracks the latest releases from Kubernetes and adds a few bits and pieces that everyone needs for managing the cluster itself. It exposes the declarative configuration framework that Kubernetes is known for. And it's also infrastructure agnostic. It will fully support bare metal, virtual machines, and pretty much anything on premises or cloud. It fully supports all the major Linux distributions, including obviously SUSE Linux Enterprise. And it serves as a container, so it will just run. It doesn't need any specific Linux distribution to run on. RKE command line interface is very simple to use. To install a new cluster, upgrade or downgrade, rollback, and you can also you can do both from the command line, or you can also use the brancher to do it. You can also recover the whole cluster in a matter of minutes. RKE supports recurring and also one-time etcd snapshots. Cluster upgrades, they're quite hard to do, and so that's why it's a big focus for RKE. The Kubernetes is a project that moves very fast. They've got very short life cycle, and as you create clusters, you will need to upgrade very often, very soon, very quickly. And so you don't really want to end the downtime for that. So this is why RKE it works very well on those cases. And it also has a rollback feature. So if something goes wrong, it's actually quite simple to roll back and if your cluster fails to upgrade for whatever reason. On the other hand, K3 is very lightweight. It's also CNF certified and is aimed at edge deployments. It is also very handy tool to use on development environments. It comes as a single binary with everything you need to start your clusters. Because it's lightweight, it also lends itself very well for short-lived ephemeral clusters in resource-constrained environments. K3S runs on different platforms, as long as the binary is supported, like x86, ARM. You don't need data center type of servers to run it. You can run it on very low machines, like you can actually run on Raspberry Pi. And at the same time, you can combine it with Fleet or GitOps or any other brancher for doing applications and Kubernetes lifecycle management. So it's very fast to stand up. You can very quickly have very thousands of them created and then manage them all with brancher. The other thing that Rancher comes with is Fleet. Fleet is an open source project that is used for GitOps. When using Rancher, Fleet can be used as a continuous delivery tool. In Fleet, the idea is to maintain the IT operations configuration in a Git repository. The Fleet controller lives in the managing cluster. Users interact with the Fleet through kubectl directly or through the API. When DevOps or IT users want to change the configuration, they submit a pull request in the Git repository, which is a single source of truth. The Fleet controller listens for all the changes in those Git repositories and syncs the configuration automatically. The changes get packaged into bundle definitions, which are groups of manifests. You can also use Helm charts. Each cluster has a fleet agent, which contacts the fleet manager to see if there are any pending changes. Unlike any other solutions, Fleet does not push the changes to the clusters. Instead, the fleet agent pulls the changes from the fleet controller. This is a crucial element of the architecture as a downstream clusters. You don't need reliable connection to the management control plane. This also relieves resources in the fleet manager cluster. As soon as the cluster is available, is able to connect, it will get its pending updates. So in terms of, for instance, using IoT, imagine you've got 100 Raspberry Pis distributed with a poor internet connection. They could just check in from time to time to see if there are any updates, pull them out, and that's it. You got them installed. So using Fleet is a great advantage on Rancher. I think I went a bit too fast, but one of the reasons is because I want to spend more time on the demo, which is probably what you're all here to see me fail. You know that demos don't always work the first time, so let's get on to it. So this morning, before the webinar started, I built a cluster already, which is this one you're going here, this Digitalis cluster. Only did it because it takes a few minutes, and I didn't want to slow down the pace of the demo. But I can show you now the steps taken to get the cluster very simply. So you go into clusters, and then click on create a cluster. You can see all the different available options you've got in there to create. As I was saying, the presentation, it supports the big players, Amazon, Azure, and Google. You can create a cluster in there, but you can also create them on VMs from either Amazon, Azure, or any other providers. Those are not the only ones. There are more, just hidden away a little bit. So you're going to drivers. You will see there are a few more drivers you can enable for other supported platforms. Those are third-party drivers. That's why they're not enabled by default, but they should work. You're going to, before you can create the cluster, let's try create a cluster in EC2. So if you create a cluster in EC2, which is a bit more involved. So I'm saying that because you need to create, before you can do it, you need to create a template. A template basically describes what your cluster is going to look like. So we select the EC2, so the region where you deploy, the credentials you need to use to authenticate, and then we will prompt you for a few extra options, like the network you want to deploy to. And then also you can select security groups, or either use an existing one or let the branch create it for you. A few more options, like the sizing of the instance type. Let's go for a large. You can also support the instances. You can encrypt the volumes. You can select the distribution you want to use. If you're on a private network, excuse me. If you're on a private network, you can also make sure that the access is blocked by private IP addresses only. Finally, just need to create a name to the template. You can add any labels. Something I always do, like adding environment type, so environment demo. There's you go to a template, and now with the template, you can just create a cluster very quickly. Select EC2. Let's call it webinar, if you can spell it. And then we need, if you remember from the presentation, we need a control plane. And also we need workers. A good number to start with is always 3 for plenty of redundancy. So we've got a control plane with etcd, and also we've got 3 workers. You can select the Kubernetes version you want to install. You can these are the latest ones supported. Let's go for the latest, why not? If you want to change the network driver, I often go for Calico, just no reason really, just because we at Digitalis we like Calico, we partner with them. But you can use any of those if you want. Advanced options, by default it will install the Nginx ingress, which is quite handy, not having to do it afterwards. And also you can configure your backups to etcd. In this case, because the cluster is also on AWS, you can make the backups to S3, which is quite handy to get them in place and remotely rather than local backups. I don't have it configured now, so I'm not going to be able to do it. Just click on create. Good. Where's my node template? Lost the option. I'm blind. Another one.
It's the third column.
Oh God. God. Sorry about that. Let's go for the demo. Yeah, same for both. Hey, I selected. No, I didn't. There you go. Yeah, so that's gonna, I'm gonna leave that creating the background. We'll come back to it in a minute. In the meantime, I'll show you around what's in the scope in here. So one of the most important things for me is the authentication. So if you go into authentication and see the authentication providers, and you can configure your authentication to use any third-party providers, like it is sitting here. Once you configure those, you get more options. You can create roles and groups. Sorry, groups and assign them to roles. So, for instance, you can create a group called the developers and assign them a specific role, only giving them access to certain namespaces, or maybe letting them create clusters to some admins. The other thing you can do was going back into the clusters. So you can see that one's already starting up. You can go into the cluster itself, and you can explore anything that's been deployed to the cluster. And those are the pods running. So if you look into any of them, you can see the pod is there. And for the pod, you can see things like the logs. I don't know if there's any logs for this one, but you can jump into it if you let you. Not all of them will, but yeah. So log into the pod itself. The other thing you can do is if you are a command line person, you could just start up a Kubernetes shell. And come back in a second. Come on, I'll type it. Yeah, you can see you get full access to it when you cluster. The permissions you get in kubectl will be the same permissions as your role. I'm logged in as admin, so I get full permissions for everything. If you prefer to do it from your terminal, you could just download the Kubernetes configuration, and then we just use, if I were doing here, and what would it come to? Same thing. So I can now get the same level of access for my command lines. The other thing you can do, which is very interesting, is we're talking about the continuous delivery with Fleet. We're going to continuous delivery, or already have something deployed. This a Helm chart I picked up on one of the examples provided by Rancher. So just a copy and paste, nothing special. And this, you will drill into it. What all it's doing is connecting to the Git repository. It's pulling from master branch because nothing else is specified. And it's applying the changes configured on this directory to the cluster. And the cluster it applies to is the one, of course, selected in here, which is the demo cluster. So if I were to create, if I've got a cluster called demo, and then I bring up another 10 more, all with the same level environment demo, and Fleet will just deploy the same configuration to all of them. So you will have the same config, identical clusters very quickly created. You want to see what this is doing? It just installed a Helm chart. It's just a sample guestbook Helm chart configuration. That's all really. What else can I show you? Oh yeah. So the other part is the marketplace. This is where you've got some prepackaged applications created by third parties and sometimes Rancher to install using applications. Let's install a couple of them just to show you how easy it is. So if we look into EC2, I've got my nodes in here if I'm not been logged out. Yeah, go here my servers. I'm gonna put some Longhorn. Longhorn, it's a how do you explain it? It's a replicated backend storage for your nodes. So because I'm using RTE, I'm not actually using the EBS volumes provided by Amazon. I prefer to keep the storage local to the servers. So if I install Longhorn into just follow this basic UI, and with all the defaults, and you don't need to do anything. I install Longhorn, it will get the storage replicated between all my workers and presented to me as a single point of entry to use. And then I can deploy 10 applications that require storage directly into that replicated storage. And as the word implies, because it's replicated, if one of my workers dies, it just doesn't matter because all the others will pick up the load and continue running the application. If you're using Longhorn, it's probably not required if you use a managed Kubernetes, but it's still a nice one to have. It's got a really nice UI. It's very simple to use, and it gives you a lot of visibility. So that's installed already. So as you can see, I've got a new link in the left panel. So if I click on that link, I should be able to manage to log into the Longhorn. You can see this up and running. I've got 10 gigs of disk space available, spread across 3 nodes, 3 workers. Now let's do something that requires storage, like for instance, monitoring. So this is the standard Prometheus, Grafana, and alert manager stack, using as well the Prometheus operator. So going to install. In this case, I'm gonna edit some changes because I'm gonna tell it I want to use the system storage. I don't have 5 gigs, so let's give it just 2. And I want to deploy it to Longhorn. Install. That will take a little bit longer because the application is bigger. It's actually more than just one. It's 3 Grafana, alert manager, and Prometheus. We should see very quickly here coming up as the volume being created. Come on, volume. not yet, coming up. This probably just making the request for the volume now. That's what's taking a little bit longer than before. See, the volume is already being created, but it's still detached, so it means it hasn't been assigned to a pod yet. There is attached, so we've got volumes, so now that should start up in a minute or so. If I want to see them starting, I could just go into workloads, and they should be coming up in here, see, in progress. And you could even see the log if I wanted to, and not yet, need to log into there. You can see the logs for Prometheus coming up, which is already up and running. So let's exploit all of that, and now we've got a new link, which is monitoring. So let's look into Grafana. There, yes. So very simply, all pre-packaged with loads of configurations, very for you to use. You can see to, because obviously there is no data just now because some of this got installed. If you give it a few minutes, you will get loads of data in. But yeah, you can see that it's quite simple to manage and create. Oh, let's have a look to the cluster provisions. I suspect it should be by now. Not yet. It's coming up. Yeah, I think I will probably leave it in here unless you want me to show something else, and we'll move into the Q&A. No questions?
Hey everyone. So yeah, no, I'm not seeing any questions in there. So clearly, the webinar was so awesome. Everybody was able to understand it. But yeah, I mean, just to kind of reinforce what Sergio's been presenting.
Sorry, Johnny, we've got a question.
Got a question? Here we go. So we have one question from, does the platform have a trial period? I suppose I'll ask that. So Dami, all of the SUSE Rancher products are fully open source, and I know SUSE on, but they are essentially free and open source. What you can do is you can obviously purchase support, product support from SUSE around the tool. So there's no trial period. There's nothing. You can just go pick it up and run with it. But if you want to have, I mean, if you're running on a business critical production facing system, I mean, it's certainly not a bad idea to do this, to get someone on the end of the hook. But if you don't need it, you don't need it. Okay, I think that answers that question. Anybody else have any other questions? Brilliant. Well, oh, here we go. Thank you, Dami. So yeah, just to reinforce what Sergio has been showing there. I mean, basically the gist of this is what Kubernetes is a fantastic platform to manage your infrastructure, deploy things on, and all the kind of pipelines and automatic deployments and configuration. So it's very good for standardizing you on good practices around how you deploy, how you manage your infrastructure, and also how you get you sweat your infrastructure more. So you actually do leverage it more than you do with that kind of traditional VM based approach. But what we love about it is this single control plane that allows us to manage clusters and applications deployed across a wide variety of choices. And you can have, I can't remember the exact amount, but you can have, I think, tens of thousands of Kubernetes clusters all being managed through Rancher. So if you have different dev environments, on-prem, stuff on cloud, across the board, or lots of little edge deployments, or even developer things, you've got a very nice way of giving you that consistent control plane around the security, around the applications. And when you loop it in with Fleet, with what Sergio was showing you there, actually, Sergio, you should point them at your blog on Fleet.
That's true.
You really do get a very, you would spend a lot of time doing this yourself. You get out of the box, you get a very robust way of looking after your infrastructure, deploying your applications and such. So yeah, so have a look at our blogs if you'd like to know more. There's a good blog in there on security with Kubernetes and Rancher. I think there's one there on Fleet as well. We've got another blog there on K3S showing you how to harden K3S and get it deployed and all that cool stuff. Another question there is the recording going to be available? Yep, I think it will be available for you. Yep, so yeah, the recording will be available and shared to everyone to look at. Okay, I think if nobody has any other questions, anybody? Nope. Great. Okay. So thank you, Sergio, for that talk. That was really interesting. I particularly like the demo myself. And thank you, SUSE, for facilitating the webinar. And if you do have any questions after the fact, feel free to reach out to us. We'd be happy to help. But you can certainly see from Sergio's demo that you can pick this stuff up and start using it pretty easily. Okay, well if there's no questions, let's call it a day then. So thank you everyone for attending, and we'll leave it there. Brilliant.
Thank you everyone.